In this video, we're going to be discussing lines and angles, and you'll see a little bit more than what we've talked about with lines and angles thus far. First, we're going to do a little review here, see if we remember some of our algebra. What is the equation of a line with a slope of -2 and passes through the point 0, 3? Well, they tell me what my slope is. That's -2. The point 0, 3 is actually, if I plotted it, would be on the y-axis. So I actually know my slope, and I know that my line is going to pass through that point. So for this particular coordinate, I know that it's my y-intercept. So I could just go ahead and write this as y equals -2x plus 3. That's going to be the answer. But if it wasn't a 0 comma something, I wouldn't know that it's a y-intercept, and I would have to do some sort of calculating to find that. And I don't know which way you want to go about it, but you can use y equals mx plus b. And remember, we're solving for the y-intercept because we already know the slope. But this would be my x value, this would be my y value, and I can plug that in. 3 equals -2 is my slope, 0 is x plus b. And if I solve this, I'm going to get 3 equals 0 plus b. In other words, b. My y-intercept is 3, and so I get the same answer that I had already written. What is the equation of a line that passes through those 2 points? Well, once again, I need to know my slope, and I need to know my y-intercept. So the first thing I'm going to do is I identify what the slope is by using the slope formula. And that is taking y minus y over x minus x. And so we get -8 over 2, which actually is a -4. Once I do that, I can do what I did over here with the one of those 2 points. So here's y equals mx plus b. You could also use point slope form. We plug in the slope. We plug in, let's use this one, the x value of 3, and we leave b as itself, and we plug in there. So we're going to get 2 equals -12 plus b. In order to solve for b, I would add 12 on both sides, and I will get 14 as my b value. It means the equation is y equals -4x plus 14. Change 4x minus 3y into slope, or 3y equals 12, into slope-intercept form. This is just solving the equation for the variable y. Minus 4x on both sides to isolate my y term. These are unlike terms, so I keep them separate. And then divide by 3, -3. So I would get -4x over -3 plus 12 over -3. And we simplify where we can. Y equals 4/3 x minus 4. The last question here for the review says, are y equals 1/3 x and y equals -3x perpendicular? How do you know? Well, you really can tell by looking at their slopes. We have a 1/3 and we have a -3. Okay. The answer to this is yes, because -1/3 and 3 are opposite reciprocals of each other, meaning they are, one is negative and one's positive, and if you flipped them over, they'd be the same. Or flip one of them over, it'd be the same as the other one. Maybe a little more difficult to see that, because 3 isn't a fraction, but it's actually 3 over 1, negative 3 over 1, and positive 1 over 3. And so those are opposite reciprocals. Okay, so now we're going to get into it. We do want to talk about a word that has been mentioned in class before, besides parallel here. We know that parallel is when two or more lines lie in the same plane and never intersect. Well, usually you just were told that it was two lines that never intersected. Now we have to add in the phrase in the same plane, because we do deal with 3 dimensions. And that's because there are two lines that could be not intersecting, but they're not parallel. They're not in the same plane though. And that's called skew lines. Lines from different planes that never intersect and are not parallel. Well, I guess if they were parallel, they'd be on the same plane. So that sums it up just fine. This is the indicator. It looks like arrows, but this is the indicator that these two lines are parallel to each other. If we had a second set of lines within the same diagram, we would use the 2 arrows as indicated there. The vertical parallel lines is how we say parallel, or a notation for parallel. Line L is parallel to line M. From the diagram, we are asked to give a couple examples of this. For the cube to the right, list the following. A pair of parallel lines. Okay, I'm going to say AE, segment AE is parallel to segment BF. Okay, AE is also parallel to segment CG or segment DH. A pair of perpendicular lines. Let's stick with AE is perpendicular to CA, okay, because they form at this 90-degree angle there. They form that 90-degree angle. And a pair of skew line segments. So that would be like, let's stick with AE and CD. See, they don't intersect with each other. Even if they were extended, you wouldn't have intersection, but they are definitely not parallel. Okay, parallel line postulate. For a line and a point not on that line, there's exactly one line parallel to the line through that point. And that's wordier than it sounds when you just draw it out. Here's a line. Here's a point not on that line. There's only one line that can pass through that point and be parallel to the first line. Perpendicular has a very similar relationship. For a line and a point not on that line, there's exactly one line that's perpendicular to the first line and passing through that point. And now we're ready for a new word called transversal. It's a line that intersects two distinct lines. The root word trans is across, like transcontinental, going across the continent. And so this is a line that goes across other lines. Here we have transversal T going across lines L and M, and then we have another diagram with transversal T going across lines L and M. When you have a transversal, you create at least 8 angles here, and the ones that are between the other two lines are called interior angles, whereas the ones on the outside are called exterior angles. So interior, exterior. And we're going to talk about these angles quite a bit in the next couple days. Here's another diagram to kind of explain and then give some names to the relationships of some of these angles. So 3, 4, 5, and 6 are all interior angles. 1, 2, 7, and 8 are all exterior angles. Corresponding angles are angles like 1 and 5. You see there's this group of 4 right here, and there's this group of 4 right here. And 1 is in the upper left of that group of 4, and 5 is in the upper left of that group of 4. So they are corresponding. Corresponding is a word that we do use in normal language. Understanding that relationship can help us with corresponding angles in math. Alternate interior angles. Alternate interior. Well, here are the interior angles. The alternate means, the alternate part of that means the opposite sides of the transversal. Okay, now it's not angles 5 and 6. They are opposite of the transversal, but we already have a name for those two angles. They are a linear pair. Okay, we want to, any of these new phrases here are going to relate an angle from the first group to the second group. And that being said, alternate interior angles would be angles like 3 and 6, or 4 and 5. Now that we've established that, alternate exterior angles would be angles like 1 and 8, or 2 and 7. The last is same side interior. Same side interior. Same side meaning same side of the transversal. So here's transversal T. Same side is 3 and 5. Those are same side interior. And also 4 and 6. And you might be thinking, what about same side exterior? In some texts, they do mention same side exterior. We never have, but the relationship is similar. We'll figure that out later. It's not one of our relationships that we name in this class, though. Different texts may also use different descriptions for the same side interior. It might be called consecutive interior or co-interior, but they all represent the same set of angles. Determine all newly defined angle relationships in the diagram below. So corresponding angles. Corresponding means same position, but different group. So angles 1 and 5. Angles 2 and 6. Angles 3 and 7. And angles 4 and 8. Those are all the corresponding angles. Alternate interior angles. Well, we look at the interior angles 3. Alternate of that would be 6. 3 and 6. Let me use plus signs a little quicker for me. Also 5 and 4. I'll put 4 and 5. Okay. Now taking a look at alternate exterior, 1 and 8. I'll use different color. 1 and 8. And 2 and 7. Same side consecutive or consecutive interior angles. Same side 3 and 5. They're on the same side of the transversal. And 4 and 6. Okay, let's practice it a little bit here. What is a corresponding angle to angle 3? Now there's only one answer to this. Angle 3 is in this group, while the others are in this group. Angle 3 is in that position. Angle 1 is corresponding to angle 3. Alternate interior to angle 7. Here's the transversal, which I hadn't identified in the first example, but we want to be on opposite sides of that, but in interior and from different groups. So here's 7. It would be angle 2. An alternate exterior angle to angle 4. Same idea, except now we are on the outside, angle 4, and angle 5 are exterior. A consecutive interior angle to angle 3. Angle 3 is right here on the inside. Angle 2 would be consecutive interior. Corresponding to angle 8, here's group that has angle 8 in it. Corresponding to that would be angle 6. Vertical to angle 2, vertical angles don't ever require a transversal. 5 and 2 are vertical. Same side interior to angle 6. Here's angle 6. We want to stay on the same side as the transversal, and we want to stay in the interior. That is angle 7. So that's a little bit of practice of identifying that relationship. It's very important that we know that for the upcoming lessons. A little more practice with this. The first diagram represents what? I'm going to type this, it might be a little quicker. The first diagram represents alternate interior angles, as they are on opposite sides of the transversal, both in the interior though, from different groups there. This represents parallel lines. Those double arrows are meaning there. These two angles represent a linear pair, something that we learned prior to today's lesson. These are in the same position from different groups, and that is corresponding angles. These two, something we learned prior to today, are vertical angles. And those two are alternate exterior angles. And just like a linear pair, we know the relationship will always be supplementary, and vertical angles will always be congruent. We will learn something about these alternate interior angles, alternate exterior angles, corresponding angles, and same side interior angles. Under certain conditions, they have special relationships. And so that wraps up the lesson. Make sure you can identify these pairs of angles, and good luck on your work. If you need anything, let me know.